Hello everyone, and welcome to this theory recording on sinusoids and phasors. So we're going to be looking now at the final section, which is circuit analysis, and we're going to be typically looking at how to then apply what we have learned in the chapter to your circuit analysis with AC sources. So in the example we're going to look at, we have an AC source, and the source will have resistor, capacitor, resistor, and an inductor. The inductor value will be 10 henries, capacitor value is 1 farad, and the source value Vs is going to give us 20 cos of omega t plus 30 degrees, where omega is equals to 2. So therefore Vs is going to give us 20 angle 30. And the question will read, determine Vx. So how are we going to determine Vx? So the first thing would be for us to first get everything to 1 unit, right? We've got farads, ohms, and henries. So we first get ZL, which is J omega L, which is going to be J2 times 10, which is J20 ohms. So we know that this is J20 ohms. We get ZC, which is minus J over omega C, minus J over 2 times 1, which is minus J 0.5 ohms. Right, now we can think about how we're going to approach this circuit. We're looking for Vx, and we can simplify this circuit. So assume that this had all resistors. We could have then put this combination in series and then put it in parallel with this combination. We'll still have Vx, and then use voltage division to find Vx. So we're going to follow that same procedure where we're going to say the resistance, and we're going to put a block here where this block will still have a voltage drop of Vx, and we're going to call the block Z, and that's 6 ohms, 20 angle 30. What will the equivalent impedance there be? It must be Z equals 3 plus J20, and that must be in parallel with negative J 0.5. Alright, so it's 3 plus 20i, which is in parallel with negative 0.5i, and this will give you a value of, in rectangular form, a value of 1.9 times 10 to the negative 3 minus 0.51 ohms. Right, and we can quickly just double check that. 3 plus 20i inverse plus negative 0.5 inverse, then that gets inverse, so that should give you that final answer. Right, and we can get that in polar form. That gives us 0.51 angle minus 89.7. Right, so now we can then use voltage division to determine the voltage Vx. So we can say Vx is going to give us 0.51 angle negative 89.7 over 0.51 angle negative 89.7 plus 6 multiplied by 20 angle 30, and that's the normal voltage division. So this is going to give you an answer of, in polar form, it's going to give us an answer of 1.7 angle negative 54.9, and that will be volts, and that would have been the voltage. If they had asked for us to determine the current, let's say they wanted the current I, we would have said the current I is given by 20 angle 30 divided by 6 plus 0.51 angle negative 89.7. So that would give us 20 angle 30 divided by 6 plus 0.51 angle negative 89.1. And that gives us a value in polar form of 3.31 angle 34.85 amps. And this is a typical example of how we would then go about dealing with circuit analysis with sinusoids and phasors. Thank you for watching this video and enjoy the course.